Hello everyone, happy to see you here. Welcome back to my channel. Today we have a really interesting equation, x cubed minus x squared equal to 18. We need to solve this equation for x. So if you have your answer, your solution, you can write it in the comments below and then we will check your answers. Okay, so first of all, let's write this 18 on the left side with the negative sign, of course. So we have x cubed minus x squared minus 18 and equal to 0. Right now, instead of this 18, let's write the difference, 27 minus 9. Okay, let's do it. So we have x cubed minus x squared minus, instead of this 18, let's write 27 minus 9 equal to 0. And right now, let's open our parentheses. So we have x cubed minus x squared minus 27 and plus 9. And a lot of students might be asking, why do I choose this combination like 27 and 9? Just look at it on the left side. So 27 right here can be written as 3 times 3 times 3. So we can write this 27 as 3 cubed. 9 right here we can write as 3 times 3. So we can write 3 times 3. We can write this 9 as 3 squared. And right here in the beginning we have x cubed and x squared. So then we can group our cubes right here and our squares. So let's do this. First of all, let's change this 27 by 3 cubed. Let's do it. So we have x cubed minus x squared minus 3 cubed and plus 3 square. So I really hope you understand this first part, first step. Right now, as I said before, we have x cubed, we have 3 cubed, we have x squared, we have 3 square. Okay, and right now let's group it. Let's group our cubes and let's group our squares. First of all, let's start with the cubes, for example. So we have x cubed minus 3 cubed minus x squared minus 3 square. So I really hope you understand it. And right now, why do we group all of this together? Because in first parenthesis right now we have difference of cubes. In this parenthesis we have difference of squares. And all we need to do, we need to remember a really great school formula. First of all, difference of cubes. Let's do this. So we have a cubed minus a b cubed. Yeah, this is our first formula. As a result, what do we have? A minus b. And another parenthesis, a squared plus ab and plus b square. So this is our first formula. Difference of cubes, we're going to apply it right here. And the second formula, all-known formula, I think everyone knows about this formula, a squared minus b squared. Difference of square, maybe the most popular formula, I would say. So we have a minus b times a plus b. A plus b. Okay, right now let's apply these formulas. Difference of cubes right here and difference of squares. A difference of squares right here. Let's do it. So we have x minus 3. First of all, difference of cubes. X minus 3. In another parenthesis, we have x squared plus 3x and plus 9. And another part, we have difference of squares. X minus 3 and x plus 3. X minus 3 and x plus 3 equal to 0. Okay, I really hope you understand this step. What we're going to do next, let's look at this question from another angle. We have a lot of parentheses, but we have one same thing. We have the common things, x minus 3 right here and x minus 3 right here. So let's factor this x minus 3 as a common. So let's do it. So we have x minus 3. And in parentheses, what we have? We have this expression, x squared plus 3x and plus 9, yeah, plus 9. And from here we have x plus 3, so minus x plus 3 equal to 0. Really great. Right now we can't simplify this more. We have x minus 3, but let's simplify this expression in another parenthesis. So we have the same beginning, x minus 3. And in another parenthesis, we can actually get rid of this parenthesis right here. We just need to change this sign to the opposite one because we have minus. So we have x squared plus 3x plus 9 minus x and minus 3. Okay, final step. Let's simplify this. We have x minus 3, so the same beginning. So we have x minus 3. And in another parenthesis, we have the same beginning, x squared, 3x minus x plus 2x. 9 minus 3, we have 6, so plus 6 equal to 0. So right now we can easily say, okay, we factor our question. We have a product of two parentheses, and a product of two parentheses equal to 0 when the first parenthesis equal to 0, so x minus 3 is equal to 0, yeah, x minus 3 is equal to 0, and second parenthesis, x squared plus 2x plus 6 equal to 0. So another branch, yeah, we have x squared plus 2x plus 6 is equal to 0. Really great. Right now, let's solve this. We have two equations, linear equation and a quadratic equation. Let's start, for example, with the linear equation, x minus 3 equal to 0. From here, our x first is equal to 3. This is our first root, x first equal to 3. What about this one? This is a quadratic equation. Of course, this is up to you. I'm going to solve it with the basic method of coefficients. So from here, what do we have? We have a equal to 1, b equal to 2, and c equal to 6. Okay, let's start, for example, with the discriminant. Let's solve discriminant at first. So we have d equal to b squared minus 4ac. So we have b squared, 2 squared, minus 4 times a times 1 times c. So equal to, we have 4 minus 4 times 1 times 6, we have 24. So our discriminant is equal to minus 20. So it means that our discriminant, first of all, is less than 0, but it also means that right here in this branch we have two complex roots. Not two real roots, but two complex roots. Okay, we already know it, and right now let's solve this part. So x second and third, because we already have x first. So x second and third equal to minus b plus minus square root of discriminant and all over to a. As a result, what do we have? Minus b, we have minus 2 plus minus square root of discriminant, square root of minus 20, and all over to a, 2 times 1. All right, this square root of minus 20, we can rewrite it in a different way. We can write it as square root of, so just look at that. So we have minus 2 plus minus square root of, we have square root of 4 times 5 and times minus 1. This is a great way, how can we express this minus 20, because we can split it, we can write it as, just look at this part, 1 second, right here, yeah. So just look at this part, we have equal, minus 2 plus minus. We can easily split it because there is really interesting, a really great property. When we have square root of a times b, we can write it as square root of a times square root of b. Okay, and we can easily split it like square root of 4 times square root of 5 times square root of minus 1 all over 2. Really great. Right now, square root of 4 equal to 2. This is our imaginary unit. This is our I. So as a result, from here we have minus 2 in the beginning, plus minus 2i square root of 5, yeah, and all over 2. Really great. And final step, we can easily split it by real part and imaginary part. We can write it as minus 2 over 2, so we can divide this numerator by parts, by these two, plus minus 2i square root of 5 over 2. And from here we can easily cancel these 2, yeah, and we can cancel these 2, yeah. As a result, we have minus 1 plus minus I square root of 5. I square root of 5, and these are our two complex roots right here. And right now let's gather all this knowledge together, and let's write our final answer. So our x first equal to 3, and our x second and third equal to minus 1 plus minus I square root of 5. Yeah, really great. This is our answer. So these two roots are complex root, and this one root is real number root. So we have 3 roots, and in the end, let's check real quick our x first equal to 3. So let's rewrite our equation. For example, let's do this on this side, on the bottom. So we have x cubed minus x squared equal to 18. As a result, when we plug in 3, we have 3 cubed, 27, minus 3 squared minus 9 equal to 18. So everything is great. So our root is absolutely correct. So 3 roots, x first real number root, x second and third to complex root. And right now I'm going to say a few really interesting hints, because right here we have x cubed, and a lot of students might be saying, okay, I just want to solve this question by inspection, and right now I say, okay, 1 not good, 2 not good, and when we plug in 3, this is a correct answer. And a lot of students say that x equal to 3 is 1 and only 1 root, and they forget about this part with the complex root, you know. And it's extremely important thing, because you forget about 2 roots. And you can't say that I solved this question completely. You solve this question completely if you scan, for example, we have this equation. When you say, okay, according to a fundamental theorem of algebra, 3 is the highest power, third power is the highest power, so it means that I will have 3 roots in total. It tells us like the fundamental theorem of algebra, and in the end you have 3 roots. It's a full and completely great solution. But if you solve a cubic equation with 1 real number root, it means something went wrong, because you forget about 2 complex roots. So every time you have doesn't matter, quadratic equation, just look at it. So we have 2 as the highest power, so it means 2 roots. We solved it completely, we find our 2 roots. Linear equation right here, x minus 3, it means x equal to 3, only 1 root, because 1 is it's the highest power. Okay, and I really hope you understand my thoughts. If you have third power, it means 3 roots in total. And don't forget about complex root, because if you solve this question by inspection, a lot of students solve this question by inspection. They might be saying, okay, x equal to 1 not good, x equal to 2 not good, x equal to 3. When we plug in, we have a great expression, so x equal to 3 is a correct answer. And they solve this question with 1 or 2 lines, and it's completely wrong. So every time you have an equation, for example, you see it in your exam, you have this equation. Every time you have it, just look at what is the highest power. So 3 is the highest power, so it means I will have 3 roots, maybe 1 real, 2 complex, 1 real, a lot of combinations, and you solve it. You solve it with the basic algebraic manipulations. You just use tricks, you just remember school formulas like that right here, and as a result you will end up with the correct solution and a correct answer, because a correct solution is extremely important part, because you can get that x equal to 3 is only 1 root, but you forget about a solution. So a solution and a correct answer are a great aspects to solve your exam, to solve this question correctly. So it was my explanation to this question. I want to say thank you everyone for watching, thank you for supporting my channel. I really hope you understand it, but if you still have any question, write a question in the comments below. We have a really great community, a lot of students, a lot of teachers here, so I really want to say thank you everyone for being here, and for exchanging information, for writing your thoughts, your response. It's extremely great for me to see your feedback, and yeah, it's extremely great for everyone. I want to say thank you everyone for watching, for supporting my channel, for everything. It's also really great that we are here and we are studying math and we are learning something new right now. So wish all the best in life, take care of yourself and have a great day. See you in the next videos.